All right, Haley, I'm trying to help you out with the buoyant force simulation. So I'm going to talk you through kind of that idea. So hopefully you're going to be able to see this screen, which I'm pretty sure you will. But this is the first one. So it says force buoyant problem. And this was basically the image that I took off the screen where I was kind of drawing in one of the videos. So the goal of this problem is to calculate the number of people you can safely put on the raft without the raft sinking. So there's like water, and you're trying to add people to the raft. So all I did was kind of analyze the forces that were acting on the raft. So the arrows here, let me just kind of go through. So we got FB, sorry, hold on a second. Okay, sorry, it's gonna ring a little bit, but I apologize. So FB is the buoyant force. So you're just gonna use the buoyant force equation to figure that out. So the fluid density times the volume that is submerged. So you're gonna submerge the whole raft. So this is going to be the total volume of the raft. And then G, which is just 9.8. So you're going to put those in for that. So you can calculate that right away. So they give you the fluid density, they give you the volume of or they give you the dimensions of the raft, so you can calculate the volume. So you can calculate the buoyant force, which is essentially like the most the water can push up on the raft. So that's this first term in this formula. The other two forces you're going to need to calculate are the weights of the person and the raft. So it's basically the force of gravity on the raft and the force of gravity of the people pushing down on the raft. So I think in the video I talk about, like, if you just had the raft and you try to push the raft all the way under the water is going to push up more than the raft, but you just have to calculate that force pulling down. So the weight of the raft pulling down, you can calculate from the mass of the raft times gravity, because again, just the formula we talked about with forces, G equals mg. So again, gravity is 9.8 and m is going to be the mass of the raft. And they don't tell you that right away, but you can calculate it because they tell you the density and they tell you the volume. So you can get the mass by rearranging this formula. So it's kind of like density equals mass over volume. I think I changed it for your class. I didn't call it P anymore, so I apologize. So this is the density of the raft, and this might be the density of the fluid. So if it's D or if it's P, it doesn't really matter. It's just the letter that it represents. So we're going to look for M. So you would take the density times the volume to get the mass. You've already calculated the volume. That's in meters cubed, and then the density should be in kilograms per meter cubed. So when you multiply kilograms per meter cubed by meters cubed, you get kilograms, which is what you want. So you should be able to calculate this, and I have it as negative because it's trying to pull down on the raft. I have the buoyant force as positive because it's pushing up, and then you put these extra people on. So I drew this little stick figure and I said, okay, you're gonna add people, and you're trying to calculate how many extra people you can put on. So one person might not make it sink, two people might not make it sink. We're trying to figure out how many people we can put on there safely and not have it sink. So the gravity or the weight of the people pulling down is what you're going to need to figure out. So kind of the difference in those two, what's ever left over is the gravity of the people. And when you add all these up, that would be balanced. So that would be, again with the phone, sorry. That would be the weight of the people going down. That would be the difference in those two things, because you want everything to balance out. So like if you want to put as many people on there as possible without sinking it, you want the buoyant force to be exactly equal to so the buoyant force going up should be exactly equal to these forces trying to pull down. So over here, I kind of tried to explain how to figure out the extra number of people. So people is plural. So if you just figure out one person, so it tells you like the average mass of a person on the boat, and you multiply that by 9.8, that'll be the average mass of one person. And you got to figure out this number. So for like, you just keep adding in increments of that person. So it's just like a variable. I just put a number sign here, but you're solving for the number sign. So let's say, like, just making this up to give you, for instance, let's say that the total amount of weight of the people could be 100 newtons, and each person had a mass of 1 kilogram times kind of 9.8 or 10 for that. So I'll change up the numbers, make it a little easier. So instead of making it 100, we'll make it 98. Sorry about that. Just changing up to make it simpler to think about. So if we had 98 newtons that's how many, like, that's the total weight of all the people we could put on, and every person was 1 kilogram, and I'd multiply this by 9.8. So 1 times 9.8 is 9.8. And if I divide 9.98 by 9.8, I could put 10 people on it, because 10 times this 9.8 would get me the 98. Now they tell you the mass of the person. It's not going to be 1 because 1 kilogram is not the mass of a person. 9.8 is going to be the value for gravity that you're using all the time. But what you're going to need to do is you're going to need to figure out this other number. So you're solving for this number sign. That's what you're trying to figure out when it asks for how many people, calculate the number of people you can put on the raft. So that's the first simulation. The second one is not that different. It just sort of requires you to do a little bit different kind of solving. So instead of solving for the number of people, you're looking for the total mass that you would put on there extra. So it's really the same kind of process. Like you got the buoyant force pushing up, so that's the positive force. You got gravities trying to pull down, which are negative. You should be able to calculate the gravity of the raft similarly to what we just described in the first simulation. And then the gravity of the mass is what you're looking for, and then you're going to solve for the mass. Again, be careful with converting. So you want to convert all the centimeter measurements for the dimensions into meters, so you'll get meters cubed at the end. And I would suggest converting before you put in any numbers and any formulas. And then you also want to convert grams, this mass in grams. So the box has a mass, and you want to convert that to kilograms because that's what we work in. So here you have two things to answer. You're supposed to answer the buoyant force. So once you get kind of the density times the volume times the 9.8 number, that gravity constant, you should be able to figure that out. It tells you the fluid density already, so you got that number. The volume you're going to be able to figure out from length times width times height again, and you multiply that by 9.8. So you'll be able to get that number pretty easy. This again is based on that other formula that I kind of showed over here. So the buoyant force, you got the raft or the box weight pulling down is this term. So that's just mg for the box again. And then again, I think it tells you, let me go back and look at the problem. It tells you the mass of the box. So again, you just got to convert from grams to kilograms. So you're going to take that number or whatever number it turns out to be for you, because they're different every time, and multiply it by 9.8 to get the gravity going down. And then you're going to solve for, it's not people this time, it's just some extra mass. So so this extra mass that you put on whatever object you're putting on to try to make it so what's the maximum amount this thing can hold without sinking. So you're going to solve for this GM going down, the gravity of the mass, and then you're going to take that number and divide it by 9.8 to get that overall mass of the object. So that's what you're looking for at the end, the mass in kilograms. All right, so hopefully this is helpful. Again, if you have questions, just keep emailing me. You're not bothering me, so I'm here to help. So hopefully that was good. Take care.